Okay, if you moved right into this video, I'm going to ask you in a second to go back and try this one on your own, because if it seemed hard to do, just realize that completing this table or completing these sequences is just like the sequences we did at the beginning of this unit, where these were the n values, the position of the term in the sequence, and these were the different terms. And we looked at how they were changing each time. So go back and try that on your own if you haven't already done so. But if you're still here, I'll assume that you have. And we see this sequence is decreasing by 3 each time. So if I continue to decrease by 3, this will be negative 12. And this fifth term will be negative 15. And we said that we multiply that common difference, in this case negative 3, by, well, we used to multiply it by n, but these are now x. So I'll just say negative 3 multiplied by x. And then we test our equation when x equals 1, we would have y equals negative 3 multiplied by 1, which is negative 3, and that is what we have. We should just really quickly test when x is 3. Negative 3 multiplied by 3 would be negative 9. And so in this case, we don't need to add or subtract anything from the variable term. In this case, this is the equation. I'm going to graph it by just graphing some of these ordered pairs, because, for example, this 1, negative 3 is a point on this line. The 2, negative 6 is another point on the line. So if you start graphing some of these x, y values, when the input is 1, when x is 1, y is negative 3. When x is 2 to the right, y is negative 6. When x is 3, y is negative 9. You see, these are all collinear. These are all on the same line. What would y be when x is 0? Negative 3 multiplied by 0 would be 0. So this line also passes through the origin. Now, drawing straight lines on this writing tablet is muy difícil, but I will do my best. But it's going to look a lot better on your paper. I don't really have a fix for that. I'm going to try to do better than that, though. That's pretty bad. That is pretty bad. That's honestly the best I can do. It's pretty sad. Okay, I blame Microsoft. This next sequence, this is decreasing by 3. Well, that's decreasing by 3. We have the same common difference. This would be negative 5, and this would be negative 8 when I continue that pattern. So the equation starts out the same way. But if I have my equation y equals negative 3x, we already know from up here that if I substitute x equals 1, I would get negative 3. But we don't want negative 3, we want 4. When x is 1, we want the output to be equal to 4. I would need to add 3 just to get to 0, so I need to add 4 more than 3, or 7. So if you add 7 to your rule, and this is what we did when we were writing rules at the beginning of the unit, so this isn't that different than, I mean, the only difference is we're using, instead of n and t, we're using x and y. So negative 3x plus 7, I should really try another value. I'm just going to try 4. Y equals negative 3x plus 7. If I substitute 4 into that, I get negative 12 plus 7. And that's negative 5, and that's what I was expecting to get. Okay, so let me graph some of these points. 1, 4 would be a point on our line. 1, 4. 2, 1, so 2 to the right, up 1. 3, negative 2, 3 to the right and down 2. 4, negative 5, 4 to the right and down 5. And when I draw that line, now, if you plotted those points on your paper and used a straight edge, which sadly I cannot do on a writing tablet, it might even be even more noticeable than what you're seeing on the screen. What do you notice about these lines? These lines will never touch no matter how far you draw them because they're parallel. And the reason they're parallel is they have the same common difference. This common difference is the slope of the line. You know how we've been calculating slope? Change in y over change in x? Well, think about it. The change in x from here to here is +1. The change in y from here to here is -3. Negative delta y over delta x is -3 over 1. Over here, same thing. You increase x by 1, you decrease y by 3. So the delta y over delta x is -3 over 1, or -3. This coefficient of the variable term, the common difference, has always been the slope. If I take 2 points on this line, delta y, down 3, delta x, right 1, -3. If two lines have the same slope, it only makes sense that they would be parallel lines, right? If they have the same slope, they're not going to intersect. So this is revealing that the slope has always been there in these equations. We wanted to play around with what slope meant before we revealed that to you. Okay, so for your notes,